Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with mechanics of solids in the topic of complex stresses and plane stresses. So the problem is a 5 mm thick aluminum plate has the width of 300 mm and the length of 600 mm subjected to a pull of 15,000 Newton and 9,000 Newton respectively in axial and transverse direction. Okay, so in the axial direction, so we having the 15,000 and in transverse direction, so 9,000 Newton is the load is acting. Okay, so then determine the normal, tangential, then resultant stresses on the plane 40 degree to the greatest stress. Okay, so now we can take the area. So area equal to, so the 5 mm thickness, so 5 into, so the thickness, so the width is 300 mm, so 5 into 300. Okay, so now we got the value of 1500 mm square. Okay, so now we can take the axial stress, that is sigma 1 value. So now load divided by area, so now the axial load is 15,000 divided by area is we found out 1500. So now we got the value of 10 Newton per mm square. Okay, so this is the sigma 1, that is the axial stresses. Okay, so then we have to find out the transverse stress, that is sigma 3. So that is minor principal stress, that is maximum principal stress. So now the transverse load divided by area. So now the area will be the transverse direction. So now this is axial. So now the area of transverse direction. So now we got the value of area is 5 into 600. Okay, so the length is 600. So now we got the value of 3000 mm square. So now the transverse load will be 9,000, that is given, that is area in transverse direction is 300 mm square. So now we got the value of 3 Newton per mm square. Okay, so next thing is we have to find out the normal stress. So normal stress sigma n equal to, the formula will be major principal stress plus minor principal stress divided by 2 plus sigma 1 minus sigma 3 divided by 2 into cos 2 theta. So now the theta value will be 90 degree minus 40 degree. So 90 minus 40 is 50 degree. So this, in this problem, the maximum stress sigma is in the horizontal. So now we can take 90 degree minus 40 degree to the vertical. Okay, so the 50 degree is to the vertical. Okay, so now we can substitute all the values over here. So now the sigma 1 value is 10 plus sigma 3 value is 3 divided by 2 plus again 10 minus 3 divided by 2 into cos 2 theta, so that is 50 degree. Okay, so solving this we got the value of 5.89 Newton per mm square. Okay, so this is the normal stress value. Okay, so then tangential stress, so that is sigma t equal to, so we know the formula sigma 1 minus sigma 3 divided by 2 into sin 2 theta. Okay, so now we can substitute the value. So now 10 minus 3 divided by 2 into sin 2 theta, so sin 2 into 50 degree. Okay, so solving this we got the value of 3.447 Newton per mm square. So this is a sigma t value. Okay, so now we have to find out the resultant stress, that is sigma resultant equal to root of normal stress in plus tangential stress, that is sigma n square plus sigma t square. Okay, so now we can substitute 5.89 square plus 3.447 square. Okay, so now solving this we got the value of resultant equal to 6.82. So 6.82 Newton per mm square. Okay, so this is the resultant, then this is the transverse stress, so this is a normal stress. Okay, so this is a method we can solve the problem. Again, we'll see next video. Thank you.